continue our exploration of object-oriented programming by looking at some of the details of the magic or special methods in Python. And so what I hope we understand at the end of going through this notebook is we'll understand how Python uses magic methods to define common tasks across different kinds of objects. And we'll do this by exploring what it means to print an object, what it means to compare an object, and actually I'm not going to do what it means to add an object in this notebook. And then, of course, once we know it, we'll know how to actually define some of these magic methods. So from the Python documentation, the description of special or magic methods, a class can implement certain operations that are invoked by a special syntax, such as in arithmetic operations or subscripting and slicing, by defining methods with special names. And this is Python's approach to operator overloading, allowing classes to define their own behavior with respect to language operators. And so this is an example of how Python achieves polymorphism. So what are some of the special methods? Well, we have the double underscore init, which is the constructor. It is the method that is called when we create an instance of the class. There's a double underscore str, string, which defines how you print an object. And then, as a final example, there is the double underscore lt, which defines the less than operator. And of course, there's also a less than or equal to, equal, not equal to, greater than, equal to operators that will have the same double underscore style. So in learning how to write programs to solve your problems, you always need to keep in mind your process of abstraction. And if you recall from our first class, it's defining what are the relevant details that are related to your object, your entity, and this then becomes very involved with creating our magic methods. So let's start off with thinking about drugs. So if I were to have a base class for a drug, what do I want every drug entity to have? So for instance, does each drug have a unique identifier? And then if each drug has a unique identifier, how do I keep track of all the unique identifiers that have already been assigned to other drugs that we've created? Does each drug have a chemical formula? Does a drug have a name? Does each drug have a method of delivery, or is that something that would be more specific and would be part of an inherited class? So a method of delivery is it oral? But a drug might be a particular chemical compound, if we're thinking of that as what constitutes a drug, that could be something that could be given orally or it could be given in an IV, for example. So my next idea with this is that if I have a base class drug, then I might have an inherited class, which is a prescription that takes a drug and adds additional information to it. So in this sense, a prescription might have the concept of the prescribing provider, who wrote the prescription. And then here may be the appropriate place for the concept of a dose. How much of the chemical are we giving? How frequently are we giving it? And how are we delivering it? Are we giving it to them orally? Are we giving it to them subcutaneously? Are we giving it to them through an IV? And so these would be, I think, additional ideas that are key to a prescription that is more specific than a drug. And so then how would I do this at a class level? What would be the attributes and methods that I would add? Finally, I don't know what the right name for this would be. Amy can fill us in, but we'd have an idea of a dispensed drug. And then here I would think that maybe we would want to have information about who dispensed it, which particular pharmacist or pharmacist tech actually dispensed the drug. And maybe you have timestamps about when it was dispensed from the pharmacy, maybe when it was administered to the patient, maybe who administered it to the patient, depending on the context. And so maybe you'd have a different concept between an outpatient dispensed drug versus an inpatient dispensed drug. Okay, now let's look into the string and the rep. I don't know what the best way to pronounce that abbreviation is, but it stands for representation of the object. And so here I have some links. These both have links to the Python documentation, and I've taken the relevant excerpts out here. And I have to confess that I do not follow, almost purely from laziness, the suggested behavior of the representation function from the documentation, and that's just laziness on my part. But essentially what they want is the representation method is primarily going to be used for debugging, and so you want a very information-rich description of the class or the class instance. And they're saying it should look like a valid Python expression and should be used to recreate an object with the same value. If that's not possible, have some rich description of the class. The string method has a much different purpose, and this is for printing out and not for debugging, and should have a more convenient or concise representation of the object. So let's think about deciding how to show an integer. Might be a relatively simple example, but what about a float? We have this float which will have many digits. We probably don't want to show all the digits that are being represented on the computer. So for the example of an infinite decimal like pi or a repeating decimal like 1/3, how many decimal points do we want to show? That's going to be a decision that we make when we design our string method. So in more complex objects, the choice of how to display an object can obviously be more complicated. And so some of the things that I think about, if I'm typically going to be showing an instance in isolation, just a single class instance, then I might have a very rich display. But if I'm thinking of it, these classes are almost always going to be in large collections, and so I'm going to have tens or hundreds of these cases, then I want a very short string representation so that as I'm looking at the data, I can get an aggregate sense of it without being overwhelmed by information. So let's do some examples here with a persons class. So how would we compare persons? If we say that one person is greater than another person, is that wealth? Is that weight? Is that height? Let's start off with saying that we're going to compare people by age. So here I've got a person class, and similar to what we did in previous examples, I've got a string method. I've got a representation method I got commented out, and you can see I've really kind of reversed their roles of how they Python wants us to be describing them. And then I've defined these special methods for the comparison operations. So in this case, I have the less than operator, and so it takes as its first argument self, and this is going to refer to the specific instance of the class, and then p, which will be another instance of a person class. So self and p actually have the same type, and then what I'm going to return is the result of the Boolean operator self.age is less than p.age. That will be true or false. And then we do the same thing for less than or equal to, greater than equal, so on. So you can see we have self, and we have another object, which I'm just referring to as p for person. Well, so let's evaluate this cell, and then let's create some, these are all kind of dated ages of rock stars. So we got Mick Jagger, Pete Townsend, I can't remember who Dennis Blandford is, David Bowie, Exene Cervenka, and Susan Ballion. So here you can see I'm just kind of playing around a little bit, showing that since I'm using keyword arguments, they don't have to be given in any particular order. And then if I print out the variable dB, which is an instance for David Bowie, you see this is the string this is the representation that I defined with my string method. And then if I call the representative function, I just get the default behavior that this object inherits from the base class object, which is saying where it's defined and then its memory location. If I come back up here and actually define a repr method, redefine these instances of it, then now I get a different behavior when I call the repr function. So we can do some various comparisons here. And so is Mick Jagger less than Pete Townsend? So our comparison here is, again, based on age. And so we get a false that Mick Jagger is older than Pete Townsend, true that Mick Jagger is older than Pete Townsend in this case. All right. So what if we wanted to compare by name instead of age? So I create a new person class here and did a little difference on the repr function. So here I'm going to, since my comparison is going to be based on age, I'm just going to return the age information in a comma-separated string of last name, first name, middle name. But when I do my comparisons, what I'm doing is I'm concatenating the last name, first name, and middle names together. And then I'm asking the less than, equal to, greater than, etc. questions on these strings. So I do it both for the self instance and the p instance. And if you recall that the way that the less than, etc. comparisons work for strings is they're going to look at the first character and they'll see what its ordinal position is in the Unicode or ASCII mapping. And so if the last names are all the same, then it's going to go into the first name and the middle name and so on. So we create this class, create some more instances of these people, and now we can ask some questions. So is Mick Jagger less than Pete Townsend? In this case, that's true because Jagger comes before Townsend in the alphabet. Or as you see up here when we ask that question, that came out as false. And so forth. So in this case, I created an entirely new class, person2, from scratch, inheriting from object, and then recreating all these methods that I had previously defined for person. Well, what I should have done was to define an inherited class that inherits from person, so I didn't have to repeat all of that. So in this case, I'm taking person2, and everything is the same for person except for the comparison operators now, which now I'm creating these instances, these methods which are comparing the alphabetical order of the names. Okay, so the key conceptual knowledge, we can refine behavior by inheriting from a class and then overriding a particular method by defining a new method with the same name for that inherited class. And if we go through here, you can see we're getting the same behavior from the inherited classes. Now these comparison operators are invoked in a variety of circumstances. For example, if I'm sorting a list, the sort method is going to look at these less than, greater than, etc. methods that I've defined, And so here I'm creating a list of rock stars with my initial instances with the person class, and then doing the same thing, creating a second list based on my person 2 definitions. And then we're going through the sorting, and you can see here we are sorting based on so here's the unsorted ages cases, and then we are sorting by age. So you can see we have increasing age, and in this case we're taking the patients, the rock stars, they're unsorted, and then we're sorting, and it's using the methods that are using the names for comparisons. And now we are sorted by last name. So we got Balian, Cervenka, Jagger, Jones, Townsend, and I'm not quite sure what happened here with Dennis Blanford. Okay, and then this is just some different string and representations that I've gotten that you can play around with.